BitNets, the future of efficient artificial intelligence. Imagine artificial intelligence models that are faster, cheaper, and more energy efficient than anything we've seen before. That's exactly what BitNets promise. Developed as a new type of neural network, BitNets could mark the beginning of a new era in AI, a future where AI is not only powerful, but also highly efficient. But how does it all work? Today, we'll break down the technology behind BitNets, what makes them so revolutionary, and why they might just reshape the landscape of deep learning. First, let's take a step back to understand how current AI systems operate. Most modern AI relies on deep learning, which in turn depends on artificial neural networks. These networks mimic the way the human brain learns by using interconnected nodes, or neurons, to process data. The more complex the task, the larger and more intricate the network needs to be. This has created a trend: bigger networks, more data, and more computational power. While this approach has led to remarkable advancements, it comes with a hefty price tag. Training these massive networks can cost millions of dollars and requires enormous energy consumption. But here's the kicker. Even with all this power, these systems aren't necessarily efficient. Compare them to the human brain, which operates with far less energy while managing a wide variety of tasks. Your brain can breathe, eat, and solve a math problem without breaking a sweat, something current AI struggles to emulate. This inefficiency has led researchers to ask, how can we make AI systems more powerful and energy efficient at the same time? Enter BitNets, a groundbreaking development that could change the game. BitNets operate on a simple but radical idea. Instead of using 32 bits or 16 bits to represent the parameters of a neural network, they use just 1 bit. That's right. Each parameter in a BitNet network can only take one of 3 values, -1, 0, or 1. But here's the twist. The team behind BitNets has found a way to train these ultra-simplified networks without losing significant performance. Let's dive into how this works. In a typical neural network, each connection between neurons is represented by a number. By reducing the number of bits, BitNets drastically cut down on memory usage and computational requirements. Think of it like this. Imagine you're using a calculator. A standard calculator can handle operations like addition, subtraction, multiplication, and division. But what if you could redesign it to only perform addition and subtraction? The result would be a simpler, faster, and more energy-efficient calculator. That's essentially what BitNets do. By limiting the possible values of their parameters, they simplify the computations required for each neuron. This simplicity has profound implications. For one, it dramatically reduces the size of the models. A typical neural network using FP32 might require gigabytes, or even terabytes, of memory. BitNets slash this requirement by up to 75%, making them much easier to store and run. But the benefits don't stop there. BitNets are also faster. In traditional networks, every operation, like multiplying 2 numbers, requires significant computational power. By reducing these operations to simple additions and subtractions, BitNets speed up processing times by up to 4 times. And then there's the energy efficiency. Running a BitNet consumes up to 40 times less energy than traditional models. This isn't just a cost-saving measure, it's a potential game-changer for sustainability. AI has often been criticized for its environmental impact, but technologies like BitNets could make AI greener and more accessible. Now you might be wondering, how do BitNets perform in real-world tasks? The answer is impressive. In a recent paper by Microsoft, researchers demonstrated that BitNets could match, or even outperform, traditional neural networks on various benchmarks. For example, when tested on language tasks, a BitNet with 70 billion parameters ran 4 times faster and consumed significantly less memory than its traditional counterparts. But here's where things get even more interesting. As the size of the model increases, the benefits of using BitNets become even more pronounced. Larger models typically require exponentially more resources to train and run. BitNets, however, scale far more efficiently, making them ideal for the next generation of AI systems, which are expected to grow even larger. That said, BitNets aren't perfect. Training a neural network with parameters limited to -1, 0, and 1 is no easy feat. Traditional training methods rely on smooth, continuous functions to optimize parameters. BitNets, with their discrete values, present a unique challenge. To overcome this, researchers had to redesign both the architecture of the networks and the algorithms used for training. Despite these challenges, the potential applications of BitNets are enormous. Imagine deploying powerful AI models on edge devices like smartphones or IoT sensors. Currently, Many of these devices lack the computational power to run advanced AI. BitNets could change that by making it possible to run sophisticated models on lightweight hardware. There's also the possibility of developing entirely new hardware optimized for BitNets. Current processors are designed to handle traditional neural networks, but as BitNets gain traction, we could see a wave of innovation in AI hardware. This would further enhance their speed and efficiency, opening the door to even more applications. So, are BitNets the future of AI? It's still early days, but the signs are promising. Their combination of speed, efficiency, and scalability addresses many of the current limitations of deep learning. As AI continues to evolve, technologies like BitNets will likely play a crucial role in shaping its future. What do you think? Are BitNets the breakthrough we've been waiting for, or do they still have a long way to go? Let us know in the comments. And if you enjoyed this deep dive, don't forget to like, subscribe, and share. We'll be back soon with more updates on the latest AI innovations. Stay tuned.